Hey and welcome. Today we are going to solve find pivot index interview question. This is one of the interesting problems, so let's get into it. First example here. Basically what this question is asking for is we might find an index in the given array that if we look at the left of that index and sum every value, then look at right of that index and then sum those values as well, the left and right sum should be equal. So as in the first example here, the pivot index is 3 and the sum of values to the left will give us 11, which is going to be equal to the sum of values to the right, which is also 11. So index 3 in that array becomes the pivot index. Second example, there is no pivot index in this one since for every single element, the left and right values sum does not match. And that is why it returns -1 here. And third example, the only index that all values to the left and right are matching is index 0, because if we consider number 2 as the midpoint here, there's nothing to the left of it, so it becomes 0. And in the other hand, 1 plus -1 also becomes 0, so first index is the answer for us there. Let's see how we are going to solve this problem. So in order to find the pivot index, we kind of need a way to check for sum of values in left and right of every single index that we will iterate through. This sum would represent everything to the left and right of every element as you see in here. This is achievable with both O of n and O of 1 space complexity. The time complexity will be O of n for both, but we need to think out of the box for it. So how is that possible? In depths of this problem, there exists a hint to something called prefix sum. Basically, a prefix sum is an array that every element of it is the sum of sequence of elements until that index. As you can see here, this is the original array, but below that, as we go through prefix sum array, we actually accumulate every value up to that index to produce a value for the index that we are stepping to. Okay. Back to the problem now. Guess what? Prefix sum are here to help. But the truth is we need 2 prefix sums for that, since we might compare both left and right sums at the same time for each value. And when those values are going to collide with exact same amount from both prefix sums we generated, then that is the pivot index that we are looking for. By now, just from animations, you know which one is the pivot index, but let's continue for now. So what if we start to create a prefix sum from left side of our array? Just note that each value in our prefix sum array will be the sum of everything to the left plus the value at the current index of our array. So there's nothing to the left in this case. That means 0 plus 1 at the index that we are iterating through, which will give us number 1 as a result to put in that index. Let's do it one more time. The sum of everything to the left, which is 1 right now, plus the current value of 7, which will give us 8, and so on. And as you can see, values being added up together as we go forward. Then we will create another prefix sum array, but this time starting from right side. That will help us to access all sum values from left edge as well as all sum values from right edge to the index that we are currently. This is exactly what we need here. Okay, for now those arrows are getting a bit distracting. There we go. Now, since we have those left and right prefix arrays, all we need is just to compare those 2 values for every index. And as soon as we find a match, or better say a colliding point, we can return the current index in our iteration as the pivot index. Now let's jump into the code to implement this. First, we will initiate our result variable to -1 and then return it immediately at the end just to not forget it. Then we need to create our prefix sum arrays. They will be as the same length as the original array and initially filled with zeros. Now it's time to define first value for left prefix sum and very end value for the right prefix sum, because at the time of filling those arrays with accumulated sum of everything behind them, we might want to have an initial value. We just don't want to keep adding zeros until we finish the iteration. So for the left one, we will choose the first item in the given nums array, and for the right one, we will choose the very last item in the array. Then it's the time to fill those arrays with prefixes. Starting from left sum array, we will initiate our iteration from index 1 because we already filled the 0 index manually. Within that iteration, as we discussed, we will add up current value with the previous one. And it's the same with the right prefix sum array. The only difference is that we will start from end of the array and iterate down to index 0. Just note that we are using nums.length -2 because if we want to reach to the last value of the array, we would say nums.length -1. But remember that we already filled the last value in the right prefix array manually. So that's why we are starting from second to last index here. And again, we will sum the value we have in our iteration index with the one after it, because we are traversing from end of the array to the index 0. Now the prefixes are ready. The only thing we need to do lastly is to just compare values from each prefix and find the magic pivot index. And for that, we will do another iteration and we will use that index of I to compare both values from both left sum and right sum at the same time. If we meet that condition, we have our pivot index. And since we are already returning the res value here, if I run this, test cases are passing, and if I submit, we are in a good shape here. The biggest problem with this solution is that it will consume O of 2n space, but it is not necessary. So in order to improve our answer, we can actually get rid of 2 prefix sum arrays and then only rely on 2 computed sum values. First one will be the total sum, and second will be the left accumulated sum as we will go through the iteration. Because if we get a bit deep into this problem, let's say we just have a number that would represent the total sum of all values in the array. Then for each value in the iteration, if we only going to calculate the left sum as we go through the iteration, calculating the right sum will be really simple. It will be just as simple as subtracting the current value and the accumulated left sum from total sum. That is our right index for every value, which we can use to compare it with the left sum and then check if they match. So 27 is not equal to 0. We will pass. This cycle will keep repeating until we find a match like so. And at that point, we can call it our pivot index and immediately return that index, which in overall will result in an O of 1 constant space complexity. Now let's jump into the code to implement this solution. Okay, we're back in leetcode. We will need 2 sum values, one for total sum and one for left sum. Both of them will be 0 in the beginning. Then a simple loop that would calculate the total sum. Okay, now we are ready to calculate the right sum on the fly. We will need another simple iteration over nums array. Within this array, first of all, we will add up left sum as we go through this iteration. But more importantly, before that, we need to see if the left sum is equal to the right sum. How are we supposed to do that? By using those 2 variables that we defined. So if we subtract the current value in iteration and whatever the sum we have to the left of it from total sum, it will give us the right sum. And if that is the case, we have that magic pivot index that we can return it immediately. Otherwise, we should return -1, indicating that we couldn't find any pivot index. Now if I run this, test cases are passing, and if I submit, we are in a good shape here. Now let's jump into the time and space complexity analysis. So the time complexity will be O of n for both solutions. The first solution will have O of 3n, and the second solution will have O of 2n at the worst case. But as you know, both of them will be counted as O of n eventually. For the space complexity, it will be O of n for the first solution because of the prefix array we created, but it will be O of 1 constant for the optimized solution, since we only just had 2 variables holding some value for us. So that was it for this video. Thanks for watching, and please leave a like, comment, and subscribe to the channel. I will put the link for arrays playlist and a few other ones in the description for you to check it out. And finally, hope you enjoyed this video and stay tuned for the next one.